أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Unit number 6, Simple Chemical Reactions. The syllabus is given for the second term from unit number 4 to unit number 9. The syllabus we taught in unit number 6 is the page number 72-73, test yourself, 74, 75, 76, and exercise the question 1 and 2. In simple chemical reactions, the change can be divided into two groups, the physical change and chemical change. As we know that the physical change is the change that can be reversed. For example, there is a cane that is crushed. The cane is any drink cane like a Coke or Pepsi or any other drinks. When it crushed, it's physically changed, but the chemical composition is same. There is no change in chemical composition. So the physical change can be reversed. It can be rebuilt, and it can be in the shape that was in beginning. The second example is food is chopped. Here you can see that different food are chopped and they are mixed and makes like a salad. But we can separate it. It should be some difficult. You have to waste some more time. But you can separate these things from another. So it's also a physical change. And in example number 3, ice melts. You know that when you water put in the fridge in the temperature that is lower than 0 and in between minus, the water changes in ice. So here is also, when you put the water in the fridge, it becomes ice, and when you again put the ice in a simple weather in a room temperature, it changes its physical and it's again become water. So water and solids you can change easily through changing its temperature. So this change is also physical change. You can say that change that can be reversed easily is called physical change. In physical change, no new substances are formed. You can say that no new thing is formed. The cane crushed is a cane. Only its physical is changed. Its chemical composition is the same. So we can say that there is no new substances are made. Energy is not always given out or taken in. There is no need of energy to given out or taken in. In this situation, when the cane is crushed, only there is a physical change. And also in second example, if you can see that the vegetables are chopped and they are mixed, when you can separate again, you can separate these things, and there is also no need of any kind of energy. If you enter the energy, so the food can be cooked, and when the food is cooked, then there is a chemical change. That is not physical change, because when the food is cooked, their chemical composition is also changed. And the third one is ice melts. There is also a physical change, and it can be reversed. So the conclusion is that in physical changes, the things can be reversed. They may be sometimes very easy to reverse, and sometimes takes a time and should be a difficult, but after some efforts it can be changed. I think you understand about physical change. The second is chemical change. We learned it in previous lectures that the chemical change is a permanent change. Here in the first page of your book, the fuel burns. You know that when the fuel burns, it gives out heat, and you can use heat for any other purpose. For example, you put the petrol in your vehicles like car or motorbike, and you drive it, and but if you say that I need a petrol again, so it is not possible, because the fuel changes into heat energy and burn out, and when anything burns, that can't be reversed. The second is toast burn. These are the bread toast, and when the heat touches these toast, totally burn and change into black shape, and they are not able to eat now, because burnt things are not allowed to eat, because they are dangerous for your health. So this change is also a chemical change. Now if you crushed it and you try to make again the bread, it is not possible. And if you can do so, uh, their taste is also burned, and that is not able to eat. So this change is also a permanent change, and it can't be reversed. In the third example, the food is cooked. Here are some vegetables that are cooked. When anything cooked, it's a chemical change. You know that when you are cooked something, you add some other things. First of all, oil and heat and salt and many more, onions and something more. So its composition is changed. Now when the composition is changed, then the new substance is made and its taste is also changed. So this vegetable also change into a new thing. So the next topic is chemical reaction. How the chemical reaction took place. There is an easy way of writing down what happened during chemical reactions. It can be written as the word equation. You saw some equations like hydrogen plus oxygen. The product is water. This is also a word equation. Here is also another example. This word equation for the reaction between iron and sulfur when they are heated. Now you can write here iron plus sulfur, and the product is iron sulfate. After the reaction, when these two things added, they make a reaction, and in the result of reaction, the product is iron sulfide. And one example is also about water. The molecules of hydrogen and oxygen, when combined, they react, and the resultant, the product is water. The chemical involved at the beginning of the chemical reactions are called reactants. You can make here a question, what are reactants? The chemicals involved at the beginning of the chemical reaction are called reactants. For example, iron and sulfur, they are involved in the beginning of the chemical reaction. So these are called reactants. And the iron sulfide is the product, And you can make here another question, that what is product? The chemicals that are made as a result of the chemical reactions are called products. In the above examples of iron plus sulfur, the product is iron sulfide, and hydrogen plus oxygen, the product is water. In the chemical reactions between iron and sulfur are reactant, and the iron sulfide is product. Dear students, it is very important to understand a world equation, that in one side of the world equation there are reactants, and other side of the equation there are products. So here we are discussing two examples. The first one is iron plus sulfur, and the result is iron sulfide. And the second is hydrogen plus oxygen. The result is water. Another way of showing this chemical reaction is to use the atomic model like this. First of all, iron atom plus sulfur atom. These two are atom. Iron atom plus sulfur atom. The resultant is iron sulfide molecule. When two or more atoms are combined, they make a molecule. So here iron atom and sulfur atom, when they added, and the result iron sulfide is made here. Heat energy causes the atoms of iron and sulfur to combine, forming molecules of hydrogen sulfide. The atoms in the new compound are joined together with strong chemical bonds. Notice the number of atoms on each side of the equation are the same. This is true for all chemical reactions. Chemical reactions like the one shown above are called the endothermic because they needed heat energy to get them started. Most of the chemical reactions needed heat energy to start it, and when their composition is changed. Here is also in the above examples the chemical reactions like the one shown above are called endothermic because they needed heat energy to get them started. Reactions which give out heat are called exothermic reactions. during the reaction, when the heat is given out, some chemical reactions are very strong and they make a lot of heat. So that heat is given out, that is exothermic, and the heat that is needed to start that chemical reactions, that is called endothermic. So here is also another example. Dear student, you know that photosynthesis is the process in which the heat energy from the sun, water from the soil, and carbon dioxide from the air, when they combine, the product is glucose plus oxygen. Here is also photosynthesis and examples of an endothermic reaction. As you know that endothermic reaction is that reaction which needed heat energy to get them started. Here is also, there is a leaf, there is a green leaf of a plant, and heat from the sun, that is endothermic, because that gets them start. And there is also water and carbon dioxide. So here we say that the process uses light energy to combine carbon dioxide and water to make the glucose and oxygen. Here the glucose and oxygen in the photosynthesis process are the product, and the carbon dioxide and water, and the sunlight, these are reactants. Allah Hafiz. I hope that you have to understand about these chemical reactions, about these examples, about endothermic reactions and exothermics. I can again repeat this one. Endothermic, a chemical reaction like the one shown above are called the endothermic because they needed heat energy to get them started. And the exothermic reaction which give out heat are called the exothermic reaction. Today our lesson is completed, and today we discuss about the chemical reactions. We also discuss about word equations. Here also we discuss about reactant and products. In the equation, the ones in one side there are reactant, and after their chemical reaction, the other side of the word equation is product. I think you understand about this lesson. Okay, Allah Hafiz. Take care. Respect your parents and your elder brothers, and love to your younger brothers. It's very important. Respect each other. Okay, Allah Hafiz.